In industrial processes, we often think about motion control, but the reality is it's the motion that we want. That's what makes things work in the factory. And the motion these days, of course, is about servos. I spoke with Rebekah Jasie, motion field sales for Yaskawa America, about the Sigma X line of servos. It was an interesting chat. Rebekah, we're standing in front of a very interesting looking display that's showing some motion that is very high velocity, very precise, and it looks almost impossible to do. And this is, I understand, part of the Sigma X line.
Yeah, this is all Sigma X. This is our new line. It came out about 2 years ago, and we basically took all of the technology that we had in our previous generations and just amplified it. So this is our top of the line, most precise, our fastest, most repeatable motion system so far.
Now, you mentioned, of course, fast, precise. If you're a production engineer, mechanical engineer, you're thinking, all right, well, I've got an inertial mass, and I got to accelerate that thing, stop it. I want it to stop where I want it to stop, and I want it to stop in the same place every time. So repeatability is critical. But usually speed works against repeatability. If you move it faster, accelerate it faster, you lose the repeatability. Can you have both?
Oh, yeah. You can definitely have both. One of the great things about Sigma X and our newest platform is actually all the data that we're able to track and bring in, which really helps in the tuning of our systems, which allows for both the repeatability as well as the speed. So we're actually able to really keep that speed and the repeatability while keeping that error very low in terms of where you want your machine, where you want your axes, and where they actually are. So it's all from the data that we're able to collect.
The display we're looking at in particular uses two linears with some rotary axes, basically, and they're working together, demonstrating that you can program these things to do quite complex motion. Would you expect these to be used primarily to create complex motion, or is the sort of the big volume applications still the world I know, which is primarily linear motion?
It's still primarily linear motion, but you can use it all to create complex motion. And I just want to actually mention we have 3 different types of servo motors in this exhibit right here. We actually have our linear track that you see on the bottom, which is part of our Sigma Track series. And then we have actually direct drive sitting right on top of that, which is that thicker metal pancake that you can see on kind of in the middle there. And then right on top we have our standard rotary motors. So we actually have 3 types of servo motors just being displayed here, all creating this complex motion and all keeping very precise motion and synchronized together to keep these parts from not crashing.
Direct drive, of course, that's got a lot of appeal in a lot of ways. Cog tooth belts, gear-driven systems, there's lash. So for rotary applications, you're always fighting, of course, that repeatability problem of there's error that ripples through the systems. Is direct drive, do you think, is that applicable for every application, or there's some areas where you use direct, but you might not for others?
You definitely don't need direct drive for every application. It's very good when you really care about like the backlash and the very specific torque and precision of a system. Generally speaking, with our servo motors, we can usually just handle it with a rotary motor. We don't usually need to go to a direct drive. It's usually either a space constraint or something like that that's driving that. But our rotary motors, we have a 26-bit encoder on our Sigma X series, so we have an incredible amount of detail of data coming back and being able to keep on that mark all the time.
So it's aggregating that much data, of course. We think of a classic feedback system. So would a process engineer, for example, working with this, would they fine-tune the process once it runs using some of that feedback data? Would they automate that process, or do these generally operate so you set them up and then walk away?
I love that question. That actually brings me to some of my favorite things about Sigma X. Because of all this data that we're bringing in, we're actually using a level of AI in our servo packs to take in that data and predict what's going to happen and actually help optimize the system. So we actually have this super cool new feature called error detection. And what it is taking that data. You can set up traces at the beginning when you're setting up your machine, and it'll take traces of what this should look like, right? Because when you're setting up your machine, that's the ideal situation. So it's going to take trace data of that situation, and as you step away and 6 months down the line or whatever, as things change, as different bearings elsewhere or actuators start being used, or there's dirt compiling somewhere, our motors are actually still taking in that data, and our amplifiers are still taking in that data. And they're actually going to start optimizing the system to make up for whatever is happening elsewhere. And with that you can also set up monitors so that, if you see giant spikes in torque or something, you're given an alarm, a warning, that something is going to happen, and you can actually prevent a lot of downtime because of that warning. So there's a lot of really cool features that all this data really brings to the table.
Now that's an interesting concept from a production environment, because I'm used to a world where dirt, contamination, wear, for example, those things would kill your process, but it wasn't immediately apparent from the data stream that's happening, because of course the motor is just trying to ram that mass, through the contaminated guardrail or track, basically. So you have to sort of, like, by trial and error, figure out what's going on in this. So it sounds like you've got a system where I could be in the comfort of my air-conditioned front office and know exactly what's going on.
Yeah, exactly. That's the hope. That's what we have available, and it's just because of all the data. We just have more data that's available, more data being processed through these servo packs, and more data that's actually available to use through our controller and back to the operator. So it's just very powerful.
Rebekah, would specifying engineers order this off the shelf in standardized units, or would they order like custom configurations?
Either. We have both available. So everything you see in this exhibit, in this case, these are all standard parts. So we can give them to, you can just order them right out of our brochure. However, if you have a specific application where what's in the brochure doesn't really fit your needs, we actually can design custom linear tracks and things like that. We do custom builds and things as well. So we really have a lot of design capabilities and engineering power that sits with the Yaskawa name. So it's whatever you guys need, really.
Which industries do you expect would be the biggest users of this? It looks like a general purpose solution.
Yeah, I would say this generally is pretty general. You can really use it wherever you need. I would say this specifically leans itself more towards like assembly, just because of all the motion that's involved. But really, you can take any of our servo motors and put them in any kind of industry, from packaging to some sort of automotive situation. There's really no end of where we can find our motors, which is kind of the best part of my job, is seeing all the places we get to go.
Accuracy and repeatability with multiple applications. That's the Sigma X servo line, says Rebekah Jasie of Yaskawa America.